Welcome to the Deep Dive. Today we're looking at direct preference optimization, DPO for short.
That's right. It's a method for, well, fine-tuning large language models using human preferences. We're digging into the paper, Direct Preference Optimization. Your language model is secretly a reward model.
And this is really tackling a core challenge, isn't it? These models know a lot from their initial training.
A huge amount, yeah, from massive data sets. But that doesn't automatically mean they behave exactly how we, prefer or expect in every situation.
Right, alignment is the key word.
DPO is presented as a way to get that alignment, to steer the model's behavior more precisely.
Okay, and traditionally the way to do this has often been reinforcement learning from human feedback, RLHF.
Correct. RLHF usually involves first collecting human feedback on model outputs.
Like which response is better.
Exactly. And then training a separate model, a reward model, to predict those human preferences.
And then you use reinforcement learning, like PPO, to tune the language model to maximize the score from that reward model.
Yes, that's the typical pipeline. It's shown success, definitely, but it can be, well, quite complex to set up and run.
And maybe a bit unstable sometimes, tuning all those parts.
That's a key point the paper makes. Those RLHF pipelines can be sensitive, require careful tuning, and don't always behave consistently. It can be resource intensive too.
So DPO comes in as potentially simpler, more direct.
That's the idea. The paper proposes DPO as an alternative that optimizes the language model directly using the preference data, skipping the explicit reward modeling and RL steps.
Okay, so it claims to be simpler, maybe more stable, and computationally lighter.
Those are the headline advantages, yeah.
Yeah.
More stable fine-tuning, potentially easier to implement.
All right, so our mission today is really to understand how this DPO actually works under the hood and why it's being seen as a potentially big step forward for aligning these models.
Sounds good. So at its core, DPO kind of reframes the whole problem. Instead of reward modeling plus RL, it treats alignment more like a classification task.
A classification task. How so?
Well, the paper presents this mathematical insight. It shows that the standard objective in RLHF, maximizing reward while staying close to the original model, can actually be optimized directly with a specific loss function, using just the preference data.
So wait, you're saying instead of building a whole separate reward model, DPO somehow learns the reward implicitly just by optimizing the main language model.
That's the clever part. They found a way to reparameterize the reward function in terms of the language policy itself.
Reparameterize, meaning...
Meaning they found a mathematical relationship. It shows that you can achieve the goal of optimizing for human preferences without needing that intermediate reward model step. The optimal policy, according to preferences, can be found directly.
Okay, so it's like finding a shortcut, skipping a step.
A good analogy. It allows you to use a straightforward classification loss function on pairs of preferred and dispreferred responses.
Right, the human feedback data. You have prompt response A, response B, and the human says A is better.
And the DPO loss function basically encourages the model to increase the probability of the preferred response, A, in your example, and decrease the probability of the dispreferred one, B.
Directly optimizing the main model's likelihoods for those responses.
That's it. And it does this relative to a reference model, usually the initial pre-trained model, to keep it from straying too far.
The paper talks about a dynamic, for example, importance weight. What role does that play? Is that important?
Oh, definitely. That weighting is quite crucial for making it work well and keeping it stable.
How does it work?
It essentially adjusts how much impact each preference pair has on the update. It looks at how much the current model gets the preference wrong.
Ah, okay. So if the model already strongly prefers the correct response, the update from that pair is smaller.
Right. But if the model is incorrectly favoring the dispreferred response, that pair gets a higher weight in the loss calculation.
So it focuses the training effort where the model is most wrong about the preferences.
Precisely. It helps prevent overfitting to easy examples and focuses on correcting the actual preference mistakes the model is making.
Interesting. The paper also brings in some theory, mentioning models like the Bradley-Terry model for preferences. How does that fit in?
Right, so Bradley-Terry is a classic model for pairwise comparisons. It assumes there's an underlying strength or quality for each item.
Like each potential response from the language model.
Yeah. And the probability of preferring one over the other depends on the difference in their underlying strengths.
Okay.
What DPO does, essentially, is show that you can fit a version of this Bradley-Terry model directly using the language model's probabilities, thanks to that reparameterization we talked about.
So it connects the language model's outputs directly to this theoretical preference framework without needing the intermediate reward score.
That's the connection they make. The classification loss implicitly optimizes the parameters of this preference model as represented by the language model itself.
So putting it all together, DPO uses this reparameterization trick, applies a classification style loss with that smart weighting, and leverages preference models like Bradley-Terry implicitly.
To fine-tune the language model directly on human preferences.
And the claim is this achieves results that are as good as, or maybe even better than, traditional RLHF.
That's what their experiments suggest. They tested it across several tasks.
What kind of tasks?
Things like controlling the sentiment of generated text, making it more positive, for instance.
Mm.
Also on summarization quality and on single-turn dialogue generation.
And the results?
They found that DPO often matched or outperformed the PPO-based RLHF methods they compared against in terms of aligning with human preferences or automatic metrics.
Matched or outperformed while
Yeah.
being simpler.
Simpler and potentially more stable, yes. For example, in this sentiment control task, it was apparently quite effective at steering the output sentiment. And it achieved strong results in summarization and improving dialogue responses based on human judgments.
And a big part of that simplicity comes from avoiding the RL part, right? That seems computationally intensive.
It really is. RLHF often requires sampling lots and lots of responses from the current language model during training to estimate rewards and gradients. That's expensive.
But DPO doesn't need that sampling loop.
No, because it's formulated as a classification problem on a static data set of preferences. You just compute the loss directly on the preference pairs.
So it's more like standard supervised fine-tuning, just with a different loss function based on preferences.
That's a good way to think about it. Much closer to supervised learning in terms of the training process, making it potentially faster and more accessible.
This has been really clear. DPO seems like a very elegant approach to the alignment problem.
It does offer a compelling alternative.
Yeah.
So just to kind of recap the core idea,
Yeah, let's summarize.
DPO optimizes the language model directly. It uses a classification loss based on pairs of preferred and dispreferred human choices.
And in doing so, it implicitly figures out the reward function without needing to explicitly model it first.
Right. The key advantages highlighted are stability, avoiding the sometimes finicky nature of RL,
Performance achieving results comparable or better than complex RLHF pipelines.
and computational efficiency, because you skip the reward modeling in the RL sampling loop.
And we touched on the theory, too, how it connects to things like the Bradley-Terry model, showing that reward can be kind of baked into the policy parameters.
Yes, that reparameterization is key. And the experiments backed this up, showing it worked well for sentiment, summarization, dialogue tasks, often keeping up with or beating PPO-based methods.
Okay. So as we wrap up, maybe something for you, the listener, to think about. How might the shift towards direct preference optimization change how we approach AI alignment going forward?
Yeah, if you can get similar or better results with a simpler, more stable method, that could really influence the development of more controllable, more human-centric AI.
And what questions remain? The paper likely opens doors for more research, maybe into how well DPO generalizes beyond the training preferences or how it scales to even larger models and data sets.
Definitely areas for future work. Seeing how robust it is and how far it can scale will tell us a lot more about its full potential.
Food for thought. Thank you for joining us for this deep dive into direct preference optimization.